Hello viewers, I am Kausalya. Today we are going to solve problem 1 and 2 by nodal method. The first problem is find by the nodal method the currents IA and IB for the circuit shown below. So here this is the given circuit diagram, right? And this circuit has two voltage sources. We need to calculate IA and the current which flows in this path is IB, right? So to start with, here we are asked to solve this problem by using nodal method, right? So what is mean by node? Node is nothing but interconnection of two or more elements at a single point is known as node. For example, you see here, consider this point. In this point, we are having three elements which are connected together, right? Again, when you consider this point, again here we are having three resistors connected together, right? So this is one node and this is another node, and again whatever may be the problem, we should have some reference node, right? So that is this point, that is the other end. Okay, they are connected together, you see, that is the other end of a battery source, a resistor. Okay, they are connected together here. So this is taken as reference node, that is node number 3. Right, so this circuit totally has 3 nodes, and here we are taking the node 3 as reference node. Right, now we are going to frame expression. So here again we are going to write it in the form of matrix. Right, so depending upon the number of nodes, that is here totally we will be having the respective matrices, right? So we should not consider reference node into account. So totally we are having two nodes, therefore now we are going to frame 2 by 2 matrix, right? So here the first thing is, you see, so here we are writing in the form of current, right? So this is your current value. So current is nothing but I is nothing but V by R, right? So this is V, and here resistors are written in the reciprocal format, that is 1 by R here, right? So since we are having how many nodes here? We are having 2 nodes here. So to the first node, how many resistors are connected? 3 resistors are connected, right? So just we have to take the reciprocal of the individual resistors and we have to sum the values, right? So here you see 1 divided by 0.25, 1 divided by 1 and 1 divided by 0.5, right? So they form the first element of the matrix here, right? Again, when you consider your node 2, so when you look at node 2, again here we are having 3 resistors which are connected together. So just take the reciprocal and add together. 1 divided by 0.5, 1 by 1 and 1 divided by 0.2 here. Right. So they form the diagonal elements here. That is, you see, 1, 2 and here also 1 and 2. Right. So in the place of the diagonal elements, that is 1, 1 and 2, 2, we are having the total value of resistors that are connected together. We have to take the reciprocal, right? And the next thing is check whether any resistor is common between your nodes 1 and 2. So when you look at this diagram, you see between node 1 and 2 we are having 0.5 ohms, right? So how to represent that 0.5? Again you have to take the reciprocal. Since it is common between node 1 and 2, we have to represent it with the negative sign here. Right. So now we have framed the resistor matrix, that is reciprocal of resistors matrix, right? So here again node 1 V1 and node 2 V2, and to the node 1 what is the current that is flowing? You see 250 divided by 0.25, right? That is the current that flows towards the node 1. Similarly here 220 divided by 0.2 is the current value that flows towards the node 2, right? So here we had framed the basic expression, right? I hope I had made the concept clear, right? Here we are having 3 nodes. The third node is the reference node, so we have to leave it. So totally 2 nodes into account. Therefore, here we had framed a 2 by 2 matrix and the respective voltage sources as V1, V2 and the respective currents here, right? Here we had written in the form of current because this is a nodal method, right? Now, once you solve this above matrix, here we are having this expression, right? And the next thing is, as usual, we have to calculate the delta, we have to calculate delta 1 and we have to calculate delta 2. So how to calculate delta, once you take the calculator the values, right, determinant of this thing, that gives the value of delta. For del 1, you have to replace this first column by this value. So you see, this is our del 1, and once you calculate here, you end up with the answer like this. Again, for calculating del 2, the second column is replaced by the respective values, right? Now, we are going to calculate V1 and V2. So, V1 is nothing but del 1 by del, and V2 is nothing but del 2 by del, right? Now, we are asked to calculate the values of IA and IB, right? Again, we will move back to the problem. Here we need to calculate IA, right? So IA is the current that flows through this 1 ohm resistor. But here we know the value of V1, right? Just now we had calculated. We know the value of V, we know the value of resistor. So V by R is nothing but I, right? So just divide the values accordingly. So here V by R, that is V1 by 1. So that gives the answer as 196.154 amps. Similarly, how to calculate V, that is IB? You see, from this diagram, we know the value of VB here, right? So we know the value of V2. So V2 is nothing but, okay, we have some value. So V2 divided by 1 gives the value of the current IB. You see, IB is the current that flows through this 1 amps, right? So here IB is nothing but V2 by 1. We know the value of V2, and finally the answer is 186.54 amps here, right? So here comes the end of the first problem. Our second problem is, by nodal method, find the power dissipated in the 10 ohm resistor shown in figure, right? So this is the given diagram. So in this diagram, when you observe carefully, here we have combination of current sources as well as the voltage sources, right? So the thing is, either we should have all sources as current or all sources as voltage, right? So here the best thing is, since we are having two current sources, again we are converting this voltage source to a current source, right? So how to convert a voltage source to a current source? Again, you see, this is voltage, this is resistance, right? These two are in series. We have to convert this into a current source parallel with this resistor. So how to calculate current? 32 divided by 4 gives the value of current, right? So 32 by 4 gives the value of 8 amps, right? And that 4 ohms in series comes in parallel here, right? So this is our modified diagram, and here again we need to calculate how many nodes are present. So you see, this is one node, and this is another node, and this is another node, and here the base is considered as a reference node here. So totally here we are having 3 nodes. So now we are going to frame a 3 by 3 matrix, right? So here how to frame a matrix? Again the same thing, you see. So as usual, it will be better if you just write the values, right? 1, 2, 3, and here also 1, 2, and 3 here, right? So here as usual, this diagonal elements are nothing but the total resistors which are connected to that particular node. For example, you see, this is 1 place, right? To the first node, how many resistors are connected? Just you have to take the reciprocal. And to the second node, how many resistors are connected, and similarly to the third node, how many resistors are connected, right? So again, look back at the diagram. To this node 1, how many resistors are connected? 1, 2, and 3, right? So just take the reciprocal, that is 1 by 8 plus 1 by 8 plus 1 by 4. Again, when you look at this node 2, 3 resistors are connected, 4, 2, and 10. Therefore, 1 by 4 plus 1 by 10 plus 1 by 2. Again to the node 3, again you see 1, 2, 3. 3 resistors are connected. So you have to take the reciprocal. So 1 by 2 plus 1 by 4 plus 1 by 4. Right. So this is what which is written here. Right. So the first step is you have to fill the diagonal elements. And the next thing is 1 and 2. any resistor which is connected between your node 1 and node 2. Again, look back at this diagram. Between node 1 and 2, we are having a 4 ohm resistor, right? So just take the reciprocal with a negative sign. So minus 1 by 4 here. Then any resistor which is common between node 1 and 3. So this is your node 1 and this is your node 3. Between 1 and 3, we are having a current source, but no resistors are connected. Therefore, the value is 0 here. Right. Once this first row is over, just fill these two things as usual. Minus 1 by 4 and 0 here. Right. The next thing is check whether any resistor is present between your node 2 and node 3. Okay, common resistor. So here again between node 2 and node 3 there is a 2 ohm resistor. So here you have to write it as minus 1 by 2. Right. So now we have framed this main matrix. Here we are having 3 nodes, right? Therefore 3 voltage sources V1, V2 and V3. Now we are going to write the values of current here. So now look at this node 1. To this node 1, you see 15 amps is coming towards the node and 12 amps is moving away. Therefore the total current at node 1 is 15 minus 12, right? So this is what I had written here. And again when you look at node 2, you see to this node 2 there is no current source, right? Therefore it is 0 here. So 0. Again when you look at node 3, you see 12 amps is coming towards the node as well as 8 amps is also coming towards the node. Therefore we have to add these two sources 12 plus 8. Right. This is what I had written here. Again, when you simplify the above matrix, here we are having a simplified matrix like this. Right. Again, the same case, you see, we need to calculate the power dissipated in the 10 ohm resistor. Right. So, when you look back at this diagram, you see, power dissipated in the 10 ohm resistor. Right. What is the formula for power? So, power is generally given by V into I. Right. Once if you know the voltage here, right, you can easily calculate the value of I. So the first step is we need to calculate what is the value of V2, right? So V2 is given by this formula del 2 by del, right? So here del is nothing but once you take the determinant value of this matrix, that gives the value of del here. So just substitute the values and here the value of del is calculated as 0.2375. And the next thing is we need to calculate del 2. So how to calculate del 2? You have to replace this second column by these elements, right? So here the value of del 2. Okay, this is the determinant of del 2. So the value of del 2 is calculated as 5.75, right? I know you people know how to calculate the value of determinant. That is first one is 0.5. You have to leave this column and this row. So 0 into 1 minus of 20 into minus 0.5. Right. So 0 into anything becomes 0. So I didn't wrote. So 0 minus of this term. Again when you consider 3 you have to include a minus. So minus 3. Again you have to leave this column and this row. Right. So the remaining terms are minus 0.25 into 1 minus 0. So therefore minus 0.25 here. So once you simplify you are getting the answer as 5.75. So V2 is nothing but del 2 by del. Right. So just substitute the values and here we are getting V2. Right. So we know the value of V2 and we know the value of V2 now. We know the value of resistance now. So we can easily calculate the value of current, right, by Ohm's law. So here I is nothing but V by R. We know the value of V2. We know the value of R. So the value of I is 2.42 amps here. Right. The next thing is power dissipated in the 10 ohm resistor. So power dissipated in the resistor is given by V into I. We know the value of V. We know the value of I. So just substitute and the answer is 58.6 watts. And again we have other formula for power that is given by I square R. Right. We know the value of I, we know the value of R. So, whatever may be the type of formula we use, the final answer remains the same, right? You can use any formula. So, here comes the end of this problem. If you have any doubt, let me know in the comment section. Thank you.